Hello everybody and welcome to another distributed systems video. Actually today's video is a bit more of an operating systems video rather than a distributed systems one. What I'm looking to show you is just how much more lightweight threads are as opposed to processes. And if you remember, we were talking about in lecture 2 how threads are sometimes called lightweight processes because the amount of context switching that the operating system has to do is less. And this is because the state variables or the state information that the operating system has to switch back and forth when doing context switching, so when bringing either threads or processes in the foreground, is less for threads than it is for processes. This is because threads only store very little information about their state within themselves, and they share the information about the process that has generated them with all the other threads. So what you see here are two screens, and the first screen on the right is basically a top command that is running on my computer. And you can see, for example, that I have 134 processes in total, 3 running, there's somebody that's stuck, a number of threads, CPU usage 40% roughly, and about 8.8, let's say, gig of memory used. Now, what I'm going to do on the left side is basically I'm going to start a multi-client testing suite. In the first instance, I'm going to have a large number of processes that are going to connect to a server that is running in the background. Now, these processes will be client processes, and they'll be doing the same computation. So we're looking at basically testing assignment 0. So I'm going to run in the first instance, I'm going to run 1,000 processes doing the same computation without any local synchronization, of course. And then I'm going to run 1,000 threads doing the same computation. So in the first instance, I'm going to run this script that you see here on the left. I'm basically starting 1,000 processes in the background. Now, watch on the right what happens. So I'm running this. It's going to take a while until the processes start. Now, what I do want you to have a look at is the amount of memory that I'm using. I jumped from 8.9 gig to 11 gig, so roughly 1.1 gig, mainly because I'm starting all of these Java processes, and each one of them has roughly 20 megabytes, as you can see on the column on the right. As you can see on the left, the tests are running until I'm done running them. Let me try again. So, okay, you'll see that the tests are failing, mainly because I haven't synchronized anything on the client because I don't want to make things even slower than they are. So let me start again. I'm going to start this script again on the left, and here on the right I'm going to look again at the amount of memory that my programs are running. So again, it's going to be a while until the operating system starts things up. Everything is 20 megabytes, roughly 11 gig. So roughly it varies between 1.2 to 2 gig used. Don't worry about that exception. That one basically says that server ran out of sockets at some point. Now, if I were to do the same by running threads, and now I have this very original class name, which is, I reckon, is called calculator test 1. That's the same computation as the previous one. Look what happens. So have a look on the right at the amount of memory that I'm using. I'm going to start this, almost get immediate reply, almost no extra memory. It's roughly 70 megabytes used. I'm going to start again, have a look on the right, roughly 70 megabytes, and I'm going to run it again. The Java process will come here as the first process, and have a look at its air size, which is basically the RAM size that it's using. All right, starting this, and the Java process was roughly 100 megabytes. Starting it again, and it's 111 megabytes or 100 megabytes and so on. So we've seen that of course, it's not the CPU time that gets hammered. It's not the CPU because your CPU, your operating system, will try to run everything such that you can get your computation done, but it will be your memory that will be hit. Awesome. I hope this helps.